professor, physician, epidemiologist. I am Dr. Sri Banerjee. Hello, everyone. I'm Dr. Sri Banerjee, epidemiologist, biostatistician, faculty member, and in this lecture, in this presentation, I'm going to be going over this article by the name of Reviewing of Applied Research with an Industry 4.0 Perspective. What does that mean? Well, in simple terms, what it means is that I have available for you an additional checklist that you can use. And I love checklists. If you know anything about me by now, I love checklists because they allow for you to kind of make sure all the necessary pieces are included. So this allows for proper evaluation of all of the facets that are needed in some of the data. So they start off by talking about some of the challenges in engineering design, manufacturing design, decision support systems, shop floor control and layout. Anyway, the list goes on. But the best part of this was the mention of a much debated document put out by the ASA on p-values. And basically, there were 6 principles that were presented for statistical analysis, focusing on p-values. And also there was mention on confidence intervals, prediction intervals, estimation, likelihood ratios, Bayesian methods, Bayes factor, and credibility intervals. So there's been a lot of writing that has gone on surrounding these areas and topics. But the idea is that, a couple of things are coming out of this paper. One, that there's some wonderful checklists, and I'm going to get to them in a moment, but let me do a little bit more talking before that. So the other idea is the broad kind of two frames or two approaches that are dominant in statistics. So that's the frequentist approach and the Bayesian approach. So if you think about the comprehensive review of statistical analysis over time, classical statistics, it has kind of an algorithmic feel to it and an inferential part. So one is, kind of trying to figure out what are the proper predictors. Two is trying to determine there's a relationship between a predictor variable and an outcome variable, keeping confounders constant. And then 3 is this inferential part where you're trying to see if you can use what you have to try to make some predictions potentially about the future. So these are probabilistic properties of a procedure of interest. And this is applied to the output of procedure of interest for observed data. And so, you assess 2 things. One, you assess bias, and then 2, you assess variance. So basically, the framework is this with frequentism. There's, there's several methods for this. The plug-in substitution principle, the delta methods, Taylor series approximation I've used in many of my Cox regression models, and the application of parametric families and maximum likelihood theory, the use of simulation and bootstrapping, which is something that I'm using a little bit more of, computer-intensive numerical methods, and pivotal statistics. So, you either reject the null hypothesis in testing for an alternative hypothesis or not. This is the main way that you go about testing. So you propose a research question. This is the process. You propose a research question. You propose a null hypothesis, and then you propose an alternative hypothesis. Um, so this is the traditional frequentist approach. But we're trying to look for a new perspective, one that is kind of like error statistics philosophy. So the claim here is that, um, you know, um, if the research finding is severely tested and if it is subjected to and passes a test that probably would have found flaws where they were present, then that can be helpful. If little or nothing has been done to rule out flaws in inferring a claim, then it has not passed a severe test. But there's actually three types of models here: primary models, experimental models, and data models. So going into these different types of models may help to also understand statistics in a different way. That model building, even if you get this much out of this, that model building is a specific and important portion of statistics, then that can provide some good information. So then to the important part of ensuring quality dimensions within data structures. This is important. Data resolution. Is the data scale used aligned with the stated goal? How reliable and precise it is? Is the data analysis suitable for the data aggregation level? And that's a critical question. That's a question that many students or many young budding researchers often forget to ask. The data aggregation portion. Is there enough information for that? So there's also then data structure, data integration, temporal relevance. This is something I want you to pay specific attention to. Chronology of data and goal, generalizability, operationalization. I use this term so often, but all these questions, these four questions, are so important under operationalization that I think you should really look at these. Are the measured variables themselves of interest to the study goal, or the underlying construct? Does it make sense to include? And then we cannot stop discussing about communication. These three components of communication is crucial. And then once you have looked at that, once you have kind of figured that out, there's another checklist which is really important, which is questions for reviewing statistical analysis in applied research. So it's not enough to just run a bunch of statistical tests and everything. How has it been integrated into the study design? So is it clearly presented, all the parameters, are they clearly presented? The experiment, have power considerations been taken into account? Is there enough data collected to make the conclusions that you're making? And then, what type of, if there was any splitting or randomization, what was done? And then, you're asking out of the 6 steps, then you're asking about algorithmic and inferential methods. Is the analysis aiming at estimation, predictive, or explanatory goals? What are the goals of the study? And depending on that, you'll be running the type of analysis, and how you're going to be running the analysis will also make a difference. So, are outcomes of inferential analysis properly being interpreted? And this is important. So in the third one, this is something that is not used everywhere, but if you're using Bayesian analysis, especially, are there prior distributions? For instance, the Cauchy distribution prior is one that is used very frequently. But what type of prior are you using? Is it an informed prior? Using prior experience of data. What are the Bayesian methods used in the analysis, and what are the Bayes factors interpreted? And many of the statistical analysis packages are able to run these. So if you're able to interpret them, and if you see a lot of statistical papers in the journal, or you see a lot of just general papers using Bayesian methodology, this may be something you may want to look into. And then, of course, but any analysis is important. So number 4, selective inference. So has the study been pre-registered? Is there any false discovery rate corrections? But you know, is the presentation of findings affected by some sort of selective inference, something going on there? And then severe testing. Have the findings been tested with an option of failing the test? Um, this is talking about some sort of testing, but this may be the model that you have created. Maybe it's actually been only evaluated in a population that it was created from, not on a new population. So there's certain things you want to be looking for in models to be making sure that they're tested, and diagnostic indicators, area under the curve, ROC curves. These types of things are oftentimes very C statistic also are oftentimes very very much useful in interpreting testing. And then finally, the presentation of findings. Of course, in a causal study, are there issues of endogeneity, like reverse causation? Are there any causality arguments presented even? And, have they been generalized for the rest of the population? Um, so, you know, just thinking about some just common ideas in a data-driven approach, which promotes research, you really need to have specific goals and data and analysis pipelines in existence that work together in congruence to handle topic areas, to handle specific topic areas and methodological barriers that may emerge along the way. Um, so having knowledge over some of these algorithms and some of these checklists allows you to make sure that you have quality centers and quality data that you gather. And you're not just falling into the trap of certain things like publication bias or p-hacking or other forms of significance testing. So go over this article if you get a chance, but these are the main highlights of this article. Thank you for listening.